Welcome, everyone. Thank you for joining us for the final Weatherization Wednesday of this year's Button Up campaign. We already have a lot of people joining us, but I'll just give it a minute or so for more people to trickle in, and then we'll go ahead and get started. And if you are, as you are joining, if you wouldn't mind putting in the chat where in the state you're tuning in from and what brought you here today. We always like to see that. We have 193 people joining us so far. That's awesome. Welcome from North Hero, Woodbury, Montpelier, all over the state. That's great. Okay, well, thank you to everyone who's on the call with us today and anyone who has attended any of the previous Weatherization Wednesdays throughout the campaign. We have had record attendance this year with an average of about 60 attendees at each Weatherization Wednesday. This session is obviously boosting that average as we got over 550 registrants for today's webinar. So that's awesome, and thank you for being here. It does look like we have a full group, so I think we can get started. And we are recording this session, and it will be posted at the buttonupvermont.org website and to our YouTube after the event if you want to rewatch it or share the recording with anyone who couldn't make it today. For folks who don't know me, my name is Becca Custer. I'm a community engagement manager with Efficiency Vermont, and I'm super lucky to be joined today by my colleague, Nate Gunnish, who will be leading today's presentation. Before we get into the presentation, we realized that after doing a few of these, some people might not be familiar with Efficiency Vermont, so we wanted to make sure to give a brief overview of who we are before we get started. So for those of you who are unfamiliar with Efficiency Vermont, we are the statewide energy efficiency utility. We offer rebates and incentives to reduce the cost of energy for all Vermonters, and we help residents understand and make better use of their energy and reduce greenhouse gas emissions. So you can always check out our website, efficiencyvermont.com, or call our customer support to get started and see what services might be available to you. So just wanted to give that brief overview. And in the context of the Button Up campaign, we're just one of the many partners that supports this campaign. Other partners include our weatherization agencies, regional planning commissions, nonprofits, and utilities, and much more. So today, we are talking about heat pumps, which can be a great heating and cooling solution for many households, which Nate will talk all about. The information that's covered in today's webinar can be used as a great resource, but if folks are really interested in moving forward, we highly recommend that you reach out to one of our EEN or Efficiency Excellence Network members so that you can get a sense for what might make the most sense for your home, because every home's a little bit different. So really recommend calling one of those contractors. After Nate's presentation, we'll have about 20 or so minutes for Q&A. So if you do have questions that come up during his presentation, you can put them in the Q&A here if you're joining us on Zoom. And if you're tuning in on Facebook, you can put your questions in the comments there. We will do our best to get to as many of them as possible, but we do have a lot of people on the call. So we may not be able to totally get to your question, but we do have some help in the chat from some of our colleagues, and they'll do the best to answer your questions in the chat. Before I do hand it over to Nate, just want to mention that we will be randomly selecting one lucky attendee to win a $50 gift card to a local hardware store. We'll do that drawing after the webinar, but be on the lookout for an email from us if you are that lucky winner. Okay, I think all the logistics are out of the way, so we can get started with the presentation. So thanks so much, Nate, for joining us today and lending your expertise, and I will let you take it away.
Great. Thank you very much, Becca. And thank you, everybody, for joining us today. We're definitely talking about a question that a lot of people are wondering about, and that is a heat pump system right for you? And really specifically today, we're going to be talking about existing homes applications. So the home you currently live in, retrofitting your heat pump or your heating system, putting in a heat pump, and how to make that system work well for you. So let's get going. We're going to talk about all the different options that are out there and what's going to work best for your specific home. Something that I want to start out with right away is just to clear up some rumors here, or what if anyone has concerns, heat pumps do work. Even in the really cold Vermont winters, if your heat pump system is designed well, it will heat your home even when it is below zero. So it's worth keeping in mind that heat pump efficiency declines as the temperature outside goes down in a lot of situations. And so heating an existing home all the way, doing a full switch to heat pumps can be a pretty big lift. So we're going to talk throughout this presentation quite a bit about what your goals might be, what your objectives are when you're considering putting in a heat pump, because what you're looking to do with your heat pump is going to make a big impact on what type of system will work best for you. So which one is right for your home? Again, this is really a question of your goals. And I have listed over here on the left a few different goals that a lot of people here may be considering. That might be trying to add some comfort to your home. It might be saving some money on fuel. And it might be swapping out the whole system, going whole hog and putting in a brand new central system for your home. Might be somewhere in the middle of any of these. And with that, you should start thinking, having conversations with your family and other folks who you live with about what is right for your home and your needs, because that's going to make a big impact on what type of heat pump you will eventually choose to pursue if you do go ahead and make this investment. So a good place to start. If you are taking notes, I would recommend, write down these questions. These are really important things to keep in mind going forward, because all of these questions really impact the right system for your house. Again, what are your goals? Your goals might be adding a little bit of cooling and a little low-cost heating to one room. Your goals might be the whole house switchover. So keeping that in mind as we talk about the different technologies that exist is going to be really important. Similarly, some really important questions are how big is your house and what is your house layout? Those two things in some ways go hand in hand. Depending on what your home construction is like, you'll be able to, or you'll need to pursue different heat pump options. And we'll get into the technical details of that as we go forward. How much weatherization have you done? Do you know when the last weatherization work was done on your house, if any? And related to this question is, what's your appetite for weatherization work? How much construction are you willing to have in your home? What kind of modifications are you hoping to do in the future? So we'll talk about specific renovations that pair well with heat pump installation jobs throughout this presentation as we get going. Next, something we're going to talk quite a bit about is what is your existing distribution system? I think a lot of folks here have questions about whether or not they can retrofit a central heat pump into their current distribution system in their home. So we'll talk a little bit about the different types of distribution systems that exist and how certain heat pumps may or may not overlap with the distribution system that's already in your home. But there's some definitions that we'll need to get out when we talk about that one. So I'll get into that here in just a second. And lastly, what are your comfort needs? And I'll come to this a little bit more toward the end of the presentation, but it gets back towards the question of goals. Think about you and the people you live with. Is it all right with you? Do you like wearing flannel shirts in the winter? Is it all right with you if a few corners of the home are 1 or 2 degrees cooler than the room where the heat pump is located? Versus, do you need a lot of control and a really comfortable space? And that's totally a personal preference thing. We'll talk about how different heat pump technologies can help you achieve different comfort needs. And these are some of the takeaways that I'd really like, and we at Efficiency Vermont really want you to walk away with from this presentation. At a high level, we'll talk about some of the benefits of a heat pump. We'll also talk about the type of heat pump that is suitable for your home, and we'll go into a few different home types. We'll talk about different layouts and styles. That's gonna make a big impact on the heat pump that's suitable for you. And as I mentioned, we're gonna talk about home improvements that pair well with a heat pump. So if you're considering bigger changes to the home, that opens up some opportunity for bigger, more centralized systems. Whereas if you're not looking to make any changes in the home, you're looking at some other types of options, and we'll talk about the technical details of that here in just a second. And finally, this is a big takeaway that I'm really hoping everyone's going to walk away with, is the types of questions to ask a heat pump contractor. I'd like you to be an informed consumer. That's really important when you pick up the phone and call a heat pump contractor, is knowing the right questions to ask. That really makes a big difference in getting you started down the path towards having a warm and happy home. So those questions to ask a heat pump contractor, I think those are going to be some really important takeaways. We'll come to that right here at the end of the presentation. To get started, I do want to touch on traditional fuel-fired heating. This may be review for a lot of folks on the call. But for those of you who maybe aren't super familiar with what is already in your home, it's worth talking about the different types of fuel-fired systems that a lot of folks have, and the distribution systems that are in place that go along with each of these types of fuel-fired heating systems. First, I want to talk about boilers. I know a lot of folks on the call here have boilers. The hallmark of a boiler is water distribution. That can be steam distribution as well in certain applications. And a term that's good to know is hydronic distribution. So I might toss that phrase around as we go forward. You might read that online or hear it when you talk to contractors. Yeah, that's referring to hot water distribution, and that's typically going to be a boiler situation. A boiler burns fuel. It burns fuel at a really high temperature to heat that water up. That water is then distributed around the house via a set of circulators, valves, and pipes. Sometimes these can be tied into water heating as well. And eventually the pipes will reach emitters in the house. And those are going to be things like radiators, baseboards, heated floors. That's what these photos here on the bottom of the slide are. Radiators and baseboards. So if you have these in your home, that's an indication that you have a boiler, you have a hydronic distribution system. Next, let's talk about furnaces. So the hallmark of a furnace is a forced air distribution system. So in this case, again, the furnace is burning fuel, getting it really hot, and blowing air around the house through some kind of air handler system. The air is going to flow throughout the house via a series of ducts, and we'll talk about ducted systems as we get going. So if you're not familiar, ducts, that's the metal pathway that the hot air uses to flow around your house, and eventually it reaches some series of registers, grills, or diffusers. That's the photo here on the bottom. So again, if you're not familiar with what you have in your system or in your home, you have these types of filters, or excuse me, these types of grills where the hot air comes out of. That's how you know you have a furnace. Which one of these two systems you may have is going to have an impact on the type of heat pump that you may consider going forward. Finally, in terms of fuel-fired heat, there are systems without distribution. So this might be a space heater. Again, we're burning fuel and pushing it into the room at a pretty high temperature. Often there's Rinnai space heaters that a lot of folks have in Vermont. And these are also wood stoves. And so both of these types of systems are point source emitters. So there's no distribution. The heat isn't being pushed into various parts of the house. It's just coming from that one place where the fuel is being burned. And so if you have a wood stove, you're familiar with what this feels like. The far corners of the house take longer to heat up than the room right in front of the wood stove, just because that's where all the heat is coming from. And it's good to keep in mind how these non-distributed heat systems work, because as we talk about different types of heat pumps, some heat pumps work more like this type of point source space heater system than a distributed system like a furnace or a boiler. These are just some of the characteristics when you're thinking about fuel-fired systems. You're trying to compare your existing system with some of the benefits and challenges that come with heat pumps. These have a really high temperature distribution. When they are distributed, the distribution is via either air or water. Often these are centralized systems, so there's only one system per home. And that's important to keep in mind, because when we start talking about heat pumps, we're going to start talking about stacking systems. So you might, we'll get into this in more detail here in just a second, but you might have a fuel-fired system and stack a heat pump on top of that. That's one of the technical details that we'll address here shortly. And then some of the downsides of fuel-fired heating systems include volatile pricing. We've seen a lot of that recently, but that's really been the case for many decades now, as well as carbon emissions and other air pollutants. When you're burning fuel in the house, you're going to have air pollutants that can get into the home. So when you're thinking about the health of your family and the folks that you live with, minimizing those air pollutants, that's a great goal that you may have when you're considering heat pumps. And then before we really break down each type of heat pump, it's worth addressing the different types that are out there. We're going to have, there's no vocab quiz, but we're going to go through a lot of the vocabulary that, various contractors or resources online may use. But basically the main bins that heat pumps fall under are ductless heat pumps, ducted heat pumps, ground source heat pumps, and air to water heat pumps. Those are umbrella terms that refer to the 4 main types of heat pumps that we're going to be talking about today. And also, just so everyone's on the same page about heat pumps and how they work, this is just giving some basic heat pump anatomy. You've got your outdoor unit, and we'll talk about what different outdoor units look like depending on the system you choose. But basically, this concentrates heat from outside, even when it is cool outside, and then sends that heat to your indoor distribution equipment. Here we've got various types of distribution. You've got a panel radiator, a grill for a forced air system, as well as one of those big wall-mounted heat pumps that a lot of us are familiar with. And before we really break down the technology, it's also worth noting that the way a heat pump works, they use a lower temperature distribution than most fuel-fired systems. And that doesn't mean that the room that the heat pump is in can't get above 62 degrees. That's not what we mean by low temperature. Low temperature just means, for example, in a hot water system, your boiler might heat up your water to 180 degrees. Heat pump may work well heating up the water to 110 or 120 degrees. And as we get into it, we'll talk about some of the details of how that impacts the distribution that you will use or you may be able to take advantage of when you are considering putting in a new heat pump system in your house. So getting right into the specific heat pump technologies, let's talk about ductless heat pumps first. These are going to be the best fit for a lot of folks here on the call. They are really common. A lot of people, when they talk about heat pumps, this is really what they're thinking of. They're thinking of this big white unit mounted high on the wall. It's a wide unit and it blows warm air into the space. So this photo just gives a really good illustration of exactly what a lot of folks are thinking of when they're referring to heat pumps. But this is a ductless heat pump. Touching on that question of vocabulary, I know that's a really tricky thing that a lot of folks talk to me about, and it's a big question. Why are there so many different terms that people use to refer to heat pumps? I guess I can't answer that question specifically, but I can tell you a lot of the different terms that get used so that you can be an informed consumer when you're trying to consider what heat pump is going to work best for your house. So a lot of times a person will just call a ductless heat pump a heat pump, just because these are so common and so popular in so many applications. They might be called a one-to-one heat pump or a mini split heat pump. So most of the time when a person's referring to a mini split heat pump, I know that's a term that gets used really often, they're referring to a ductless heat pump that has one unit outside, one unit inside. I'll show you some photos of that here on the next slide, just so you can get a sense of what that means. With ductless heat pumps, you may also be referring to a multi-split or a multi-zone heat pump. And again, I'll show you a photo of the difference there, but there's no ductwork involved. There's just the outdoor unit and indoor units that distribute heat throughout the home. These ductless heat pumps operate like those point source emitters, those non-distributed fuel-fired heating systems that I was referring to earlier. So they deliver heat only into one space. And as a result, typically more than one is required to heat an entire home. It depends a little bit on the layout, but that's pretty typical that if you are trying to use ductless heat pumps to heat an entire house, you'll likely need more than one, just by virtue of the distribution that is characteristic of these types of heat pumps. Getting into some photos here, just so everybody knows what a contractor might be referring to and what I'm referring to when I'm talking about this type of unit. Over on the left, we have the one-to-one or the mini split units. So you've got 4 little units, each connected to an independent indoor unit. And so, you've got more real estate being used outside, but these actually tend to be really a really efficient way to operate ductless heat pumps is to have one outdoor unit for each indoor unit. It gives you a lot of control over the system to ensure that you have comfort and efficiency. Over on the right, this is going to be a multi-zone or a multi-split system. It's a bigger unit, as you can see, and you can see these white lines, one going up above the unit, as well as one heading off to the side. Those are the refrigerant lines that bring heat into the home, and that is having the fact that there are two lines there indicate to me that this is a multi-zone unit. So this single system outside is feeding two indoor distribution units. This is what the indoor units look like. Over on the right, I've got the same photo that I showed earlier. This is the type of unit that a lot of us are really familiar with. We've seen in a lot of homes and businesses. They're becoming really popular. There's also other options, so it's worth knowing that other options exist in case you have any aesthetic aversion to the type of heat pumps that we typically see. So on the far left, there's a floor-mounted unit, and there are also ceiling-mounted cassette units. There are some limitations as to where you might be able to use one or another, depending on your heating needs, as well as the space in your home. But these are all the different types of indoor units that you might see when you're using a ductless heat pump. Just at a really high level, these are some of the characteristics of a ductless heat pump. They are typically the least expensive option. And we'll talk about why that is. Often they're smaller units, and that makes it for a fast install compared to some of the units that we're going to talk about later on in the presentation. They're super flexible. They're versatile in a lot of different types of homes, and they can be really useful for partial fuel switching. And this really gets at the question I posed earlier of what are your goals? So if your goal is a little extra cooling and a little extra heating at a low cost in the main bedroom upstairs, one of these units can do really well for you. If your goal is partial fuel switching off of your existing fuel system, one of these units down in a main living space or main dining and kitchen area can also do really well for you. So these have a lot of flexibility to be stacked on top of existing central fuel fired systems. Some caveats that come along with installing ductless heat pumps. The home does need to be well weatherized for you to take advantage of the high efficiency and low cost operation of a ductless heat pump. You are going to want to make sure the home is well weatherized, and that has to do A, with the slightly lower temperature of distribution, and B, of the fact that there isn't distribution throughout the house, so that heat is coming from a single place. Also, because the heat is coming from a single place, ductless heat pumps can require some tolerance for temperature variation. So again, this gets back to your comfort needs. If you are going to be uncomfortable with the bathroom at the far end of the house that doesn't have heat to it being 2 or 3 degrees colder in the winter, that's just something to keep in mind. So if that's something that's really important to you, that's going to impact the type of system that you'll want to pursue. But let's talk about where they do work really well. If you already are working toward doing any kind of air sealing weatherization project, saving money on energy, and making your house more comfortable, these two things go hand in hand really well. Air sealing and weatherization help ductless heat pumps do a better job heating your home. So that's just a good thing to keep in mind. For homes with simple layouts, open floor plans, and few bedrooms, ductless heat pumps are more likely to be able to carry the majority of your heat load. And so, if that sounds like your house, these can be a really good system for you, especially if you've got downstairs, a living room, kitchen, and dining room that are all well connected. These also can, as we talked about earlier, they have a lot of flexibility, so they can pair well with, existing central heating systems and existing wood heating. So folks often wonder if heat pumps are going to carry the load for their house down in those coldest nights of the year, in the middle of January. And if you've already got a wood stove that you like using when you want to stay nice and cozy on those cold nights, those systems pair really well together. And again, because of the flexibility, these can be really useful for adding heat or comfort. And I say comfort here because you could also be adding cooling with one of these heat pumps to a particular room in the house. So lots of flexibility, lots of different options that you could use one of these ductless heat pumps in. And that's what makes these so popular and so common, and why they'll be a good solution for a lot of folks here on this call. Moving into ducted heat pumps, and as we go, we're going to move from less to more centralized systems. This one's kind of here in the middle. We'll talk about what I mean by that. So you can see from this ducted heat pump photo that I've included that this is a bigger outdoor unit. This actually looks a lot like a central AC unit that someone in a state warmer than Vermont most of the time might have. Yeah, so let's get into ducted heat pumps. There are two different types of ducted heat pumps that maybe your contractor could be referring to, and these are just both things that you should know about if you're considering a ducted heat pump. There are compact ducted, so that's the photo on the bottom left. This might not be a super familiar photo to a lot of folks here, in large part because these are often hidden away in the ceiling, invisible, because the compact ducted heat pump operates a lot like a ductless heat pump. You've got your unit outside, refrigerant lines feeding heat to this unit inside, and then that unit then has a couple of short duct runs that maybe are distributed to 2 small bedrooms upstairs. So if that's what your house looks like, that's the type of place where a compact ducted heating system works really well. Centrally ducted units are bigger. They operate a little bit more akin to a furnace in that there is a single air handler somewhere in a mechanical room or a basement, and that has ducts running out of it, and those ducts run everywhere in the house where you need heat distributed to. Sometimes ducted heat pumps can take advantage of existing ductwork. This is a big question that I know a lot of folks have. It's worth noting that this is a big sometimes. It isn't always the case, and that has a lot to do with the fact that the air that a heat pump is distributing is going to be a lower temperature than the air that a furnace or any other fuel-fired system would be distributing. So you'll hear me say this a lot throughout the rest of this presentation. It's worth having good conversations with your contractor about what your existing distribution system is like in a forced air application, what your existing ductwork is like, and seeing if that would be compatible with a ducted heat pump. You can increase the air or improve the air quality in your home with inline air filters. You're not burning fuel in the home when you're using one of these. That can be really good for the health of the occupants. Like I was talking about earlier with those compact ducted units, when you can run little duct runs to various parts of the house, these can be really helpful for reaching smaller rooms if that's something that you need for your comfort needs or to meet the goals that you have when you put in a heat pump. Some of the downsides, often these bigger systems are more expensive than a ductless system, the previous system we talked about. And that's in part because often the existing ducts will have to be altered or replaced. And that's just going to be time intensive. It's going to involve opening up the house a little bit more to make sure that those ducts are compatible with a really comfortable system. And if your home cannot run ducts, it's a post and beam home, or for whatever reason, this isn't going to be the right system for you, because in order to use a ducted heat pump, you'll need to run ducts throughout the house. Where do they work really well? They work well in places where you can put in the air handler and the ductwork. So homes with unfinished basements. So over here on the photo on the right, I have a photo of a single-story home. If this has an unfinished basement, you can run the ductwork kind of like an upside-down octopus down in the basement. You already have access to all the rooms from below. So that's a really good place. If that's the type of home you have, that's a place where you can put in one of those centrally ducted heat pumps, and that can work really well for you. They can work well, again, with existing wood heat and in other situations where you, on those coldest nights of the year, have some system that will help carry the load. They pair well with more robust interior renovations. So if you're planning on redoing some rooms, mixing things up in the house for whatever reason, and you'll have walls opened up and access to the ductwork, this is a really good option. You can jump in and make the adjustments to the ductwork that you need to make in that situation. And as I was mentioning earlier, these can reach into multiple small rooms. Again, upstairs, maybe you've got 3 little bedrooms at the end of a hall. That could be a really good situation for a compact ducted heat pump. Just to get a little duct run to each space, make sure everybody who's living there is nice and comfortable. These give you a little more flexibility. And that could be a great option. But again, a little bit more of an upfront investment, and it may require more alterations to the home to fit one of these in. So getting more towards the bigger central systems that we see. I'm going to talk first about ground source heat pumps and then air to water heat pumps. We'll talk about the differences between the two. But both of these systems they're Cadillac systems. They're going to have really high efficiency. They work really well. But part of what comes with a big central system that has really high efficiency is there's a lot of work that goes into retrofitting one of these into an existing home. And with that work comes a higher cost. We'll talk about why that is here in just a moment. Getting back to this question of vocabulary, just so everybody's on the same page, they know all the different terms that are being used to refer to each of these types of systems. These are often also referred to as geothermal heat pumps. That's a phrase that contractors and other resources will use regularly. Part of the reason ground source heat pumps are so efficient is that they use the stable temperature from below the ground as their heat source rather than air. So all year long, there's consistent temperatures that they can tap into for both heating and cooling. And that helps them run really well. And if you have concerns about those coldest nights in January, ground source heat pumps can assuage those concerns. They do have a lot more components, and I'll show you what those look like here in just a moment. But it's worth noting that you'll need some kind of mechanical space as well as an area for some excavation, because these do include a well, a water pump, the heat pump unit itself, and then the indoor distribution infrastructure. Worth noting as well that this type of system can be used in either a forced air or a hydronic distribution system. So it can work either way. In some cases, you may be able to take advantage of that in your existing home if your system is already designed for low temperature distribution. Some of the different types of ground source heat pumps that exist that we see in Vermont are open loop and closed loop systems. So I won't get too much into the details of how one works versus the other. An open loop pulls water from an aquifer below grade and then expels that water back into the aquifer. That's where that heat transfer is coming from. A closed loop uses a closed loop that has a glycol water mix inside. It gains that heat just through touching the soil below the ground where it's nice and warm all winter long. And then the heat pump pulls that heat out of the solution and then sends that back down into the pipes. Worth noting that because of reliability and consistency of results, a lot of folks are moving towards closed loop systems as kind of the industry standard these days. So that's something that you'll want to have your conversation with a contractor about when you're comparing the two different systems. Most of what we're seeing these days are closed loop systems. These are the different components of a ground source heat pump. On the left, I've got a little diagram. On the right, a real life photo. On the left, you can see a well headed down below the ground, as well as a heat pump unit. I'm not sure if my cursor is showing up on the screen for you folks, but I am circling the units here that I'm talking about. There's a heat pump unit here in the middle. Typically, these systems are going to come with a buffer tank as well for part of the system, and then the distribution. And in this diagram, you can see there's some tubing running underground or under the floor, indicating to me that this is a radiant slab. And that's the type of low temperature distribution system that works well with a ground source heat pump. Over on the right, again, you see the same components. This is the heat pump unit here, this box in the middle. And over on the right, you can see that this heat pump is being tied into a forced air application as opposed to a hydronic application. So depending on your preference, what may already exist in your home, these are viable options in both cases. Some of the characteristics, they have a really high efficiency because of the consistent temps that they can take advantage of below the ground all year long. And it is possible in some applications to retrofit them into existing heating and cooling. But I'll include in the caveats here, the bottom point that I make here is that it cannot typically be easily swapped in for an existing boiler or furnace. There's some adjustments that are usually going to have to be made. Again, this is the Cadillac system. It works really well. It brings a lot of efficiency, but it can be the most expensive option. It's really designed to heat the whole house, bring a lot of comfort. And it's also worth noting that there's a lot of drilling and excavation that goes into putting in a ground source heat pump, and that can bring the price up considerably. That's part of why these are the most expensive option out there, because that's the trade-off when you're trying to take advantage of that really high efficient opportunity that you get by tapping into the temperature below the ground. Where do these systems work really well? I've just included a photo here of a big house that I imagine has a lot of different rooms, a lot of nooks and crannies, harder to heat with, say, a ductless heat pump. So if you've got a bigger home and you're trying to put in a new central system, doing a big retrofit, that's where this system can work really well for you. Talking a little bit about the details of what I was mentioning earlier with low temperature distribution, that might be radiant flooring or panel radiators. I will note that that's a conversation you'll have to have with the contractor. Say, hey, this is the type of distribution system I have. You tell me if that's going to work with the low temperature water, because that's all going to be dependent on the house. And you can use a ground source heat pump to replace both the full load or the partial load. These can be tied into existing systems if you would like to do that as well. And finally, talking about air to water heat pumps, just like a ground source heat pump, this is a big system designed to heat the whole house. The main difference here is that rather than tapping into the temperature below the ground, you have one of these units, just like the first two systems that we saw, that draws its heat from the outdoor air. And that's what this photo here is. This is a bigger unit, 2 fans. This is able to pull heat from the outside air. Again, these are whole house systems. Typically, this comes kind of with the name air to water heat pump. These are used with hydronic distribution. So again, that's panel radiators and radiant flooring. They do have a slightly lower efficiency than a ground source heat pump because they're drawing the temperature from the air rather than the earth, but there are fewer moving parts. There are fewer components to an air to water heat pump. So that brings the cost of installation down. And in fact, the cost of installation can be similar when you're thinking of the outdoor unit to ductless and ducted heat pumps, somewhere in the middle. Here's just some photos of the different components that you're going to have in a air to water situation. On the top left, again, this is that bigger outdoor unit that's going to be drawing heat from outside, concentrating that heat, and then it's distributed inside. You can see this photo on the bottom right. There's a series of pipes and circulator pumps that are all used to distribute that warm water throughout the home and ensure that you're comfortable. Just some of the characteristics here. These are typically whole house systems. It's worth noting that even though these are hydronic systems, typically they can be tied into cooling. So if that's something that's really important to you, but this is the type of system you want, that's a conversation that you should have with that contractor because it can be done. And depending on the home, as I've come back to on a few of these, you may be able to use your existing distribution infrastructure. But as I say over here on the right, these are not typically plug and play with existing radiators. So if you've got a thin tube baseboard, that's what a lot of folks have. This isn't going to work as well for you a lot of the time. It's a really important conversation to have with anyone who would be doing one of these installations. Depends a little bit on the size of the home and really it's most important what type of radiators you already have. And as a result, that can be time consuming and expensive if you do need to replace your existing hydronic distribution. Just some photos here of what we're talking about when we talk about low temp hydronic distribution. You'll need some space down in the mechanical room or basement because you'll have a few different pipe runs running throughout the house. As we can see in this photo over here on the left, there's some various controls going into ensuring that warm water gets to all the parts of the home. One of the upsides of that is you have a ton of control, ton of comfort, but you do need the space to install something like this. And there is some cost associated with putting in this type of high-end unit. And then over on the right, this is a panel radiator. So this is the type of high surface area radiator that typically will work well with a low temperature system like an air to water heat pump. Again, where these work really well, places where you have panel radiators, radiant flooring. As you can see over on the right, I've got a photo of some radiant flooring going in. If you already have your hardwood floors down, this is going to be a little bit harder to install. So that's just something to keep in mind when you're considering this type of system. Because of that low temperature water, your distribution should be carefully zoned throughout the house. And that's another conversation you'll need to have with your contractor. And like I was saying with the ground source heat pumps, if this is a larger home where you have pretty specific comfort needs and you're really interested in investing pretty big in ensuring that those needs are met, this is the type of big, really solid system for you. I know that was a ton of information. I need to take a drink of water. We can just slow down a little bit here and talk about some of the key takeaways that you should have coming away from this now that you know some of the specific types of technology that exist. Again, these are those questions to revisit that we talked about early on. You haven't written them down, now's a great time. What are your goals? What are you trying to change in the house? How big is the house and what is the house layout? As we talked about with those different systems, smaller homes may be able to take care of more of their heating load with a ductless heat pump compared to a bigger home. And how much weatherization have you done? You're going to want to make sure your house is well weatherized in order to really take advantage of and enjoy a heat pump if you do go ahead and invest in one of these systems. What is your distribution system? That's something I kept coming back to. It's really important if you're considering swapping out a central system for a new central heat pump system. Really good conversation to have with the contractor. What kind of radiators or ductwork do you already have, and will it work to put in a heat pump and just take advantage of those already in place? And finally, what are your comfort needs? These are just some questions to ask your contractor. I think hopefully this presentation has given you a handful of questions to ask your contractor in addition to these, but just some good ones to keep in mind. What type of heat pumps do you install? Some contractors will only install a specific kind. And so if you start really working closely with them, that's going to send you down a particular path. So it's a good question to ask early. Do you bundle heat pumps with weatherization work? If you haven't done any weatherization, some folks do, some folks do not bundle those two things together. So if you're going to need weatherization work and they don't bundle those two things together, you're going to need to engage with a separate contractor. And for those bigger central systems, there's a bigger question here around how the contractor will determine the heat load and the sizing of the equipment. So for a big central system, that's a more important question to ask. And again, with a big central system, you got to really ask that question: can I take advantage of my distribution infrastructure, depending on what's already in the home? As I've shared earlier, these are typically not plug-and-play systems, but you will want to have that conversation in case you can take advantage of what's already in place. And don't forget to check out Efficiency Vermont offerings. You can reach out to us for customer support or to have any technical questions answered. And you can sign up for virtual home energy visits. That's a way to have us, you can walk us around on your phone and we can check out some of the specific details of your home. When you're looking for contractors, look for Efficiency Excellence Network contractors. I think Becca mentioned those right there at the beginning of the conversation. And also through Efficiency Vermont, you can take advantage of the Home Performance with Energy Star program. So there are rebates available there if you're trying to weatherize your home. And there on the Efficiency Vermont website and through our partner utilities, you'll be able to find rebates for heat pumps. And that can really bring the price down in really valuable ways to make these options viable for you and your family. So I hope this was informative, and let's open it up for QA. I'm sure a lot of folks have a lot of questions.
Thank you so much, Nate. That was such a great presentation. You covered so much. I was curious if you have any questions, but of course we have a lot of questions that are coming in. So I will just start reading out questions and hope to get to as many as possible in the next 16 minutes.
Great.
One of the questions we're getting, we're trying to group them into kind of themes, so we're really answering as many as possible. And I just want to thank our colleague Steve Spatz in the chat, who was rapid firing, answering questions. He's gotten to like 30 questions, so thank you for that, and we'll get to the rest. So one question we have about kind of cold weather performance of heat pumps is, how is a heat pump a good idea in Vermont since it's so cold?
Yeah, how is it a good idea? And that really depends on what kind of system you're going for. So I imagine that a big part of that question comes down to gets back to the question of when it's cold at night, a couple of the sort of really coldest sub-zero nights during the winter in January. Is this gonna fail on me? Am I gonna have frozen pipes? Am I gonna have am I going to be unhappy with a 62-degree home or a system that doesn't even work? I know a lot of folks have fears like that. And there's a couple things to note. As I was talking about earlier, these systems can be stacked with existing fuel-fired systems. So if you do have those concerns, you can have both in your home and work with a contractor to set up a control situation where you can save a lot of money, save a lot of energy by operating the heat pump down to a specific temperature. And then if the home is getting a little cold, then that furnace or that boiler knows to kick on, or you can go fire up the wood stove. So there's ways to double up there and make sure you stay comfortable and happy. It's also worth noting that heat pumps do work well. These new cold climate heat pumps that are being installed in Vermont, they lose efficiency at low temperatures, but we're not seeing them totally fail and leave you high and dry really on those coldest nights of the year. And when you're thinking about taking advantage of that efficiency, think about really how many hours a year we spend below zero. There aren't that many. It's really a few hours on the coldest nights of the year. Maybe we get a bad stretch where there's a couple days back to back where it stays really cold. But all the rest of the time when it's above zero, these heat pumps are working super well, super efficiently, and keeping you comfortable.
Great, thank you for that. Another question, do I have to install heat pumps in every room?
You don't have to install heat pumps in every room. This gets back to the question of your goals and what you're going for. So if you are trying to swap out heat pumps for your entire system, what your distribution is going to be dictates whether or not you will get access to every room. I sort of imagine this question is asking if I'm doing ductless heat pumps, the ones that so many of us are familiar with, will I need to put one into every little bedroom? And you're going to want to have that conversation with your contractor. You're going to want to make sure the house is weatherized well in order to fully take advantage of the heating of a ductless heat pump. But typically you're not going to have a single unit in each room throughout the house. Yeah.
Great. And we did have a question in the chat about what does it mean by weatherized well, if you wouldn't mind expanding on that a little bit.
Oh, sure. Yeah, great question. I was doing so much, making such an effort to define terms, but I forgot to define that one. Yeah, weatherizing your home means increasing the air sealing and the insulation values in the home. So a lot of older homes in Vermont don't have much for insulation up in the attic. They may not have any insulation down in the basement. And when you're thinking about the lower temperature air that's being distributed by a heat pump, making sure the house is nicely air sealed can really help you take advantage of that. So there are a lot of contractors around the state that will do this type of weatherization work for you. There's other things, depending on how handy you are, that you may be able to take advantage of yourself. A lot of folks, when they think of weatherization, they immediately jump to windows and doors. Those often aren't going to be the best bang for your buck. They can be expensive and you're not going to see the most energy savings long term. Whereas improving the insulation and air sealing in the attic or down around the basement, that can really make a big impact on improving your comfort, whether you put in a heat pump or not. It's actually just a good idea all around.
Great, thank you. We have a question kind of around supplemental heat. Does it make sense to use an electric space heater when it's too cold for my heat pump to keep the house warm?
Sure, yeah. So, when a heat pump is, when it's really cold outside and the heat pump is running less efficiently, in that situation, the cost savings that you get from running a heat pump versus electric resistance, so that's an electric space heater is an electric resistance system, and it goes down. It's still more expensive to run that electric resistance system for the most part, but some heat pump systems will have electric resistance built into the system to offer that supplemental heat. And when you really think about it, this gets back to the point I was making earlier about how many hours we actually spend in really bitterly cold temperatures when the heat pumps won't be operating as efficiently. There's not very many. So when the cost is going to go up as a result of you using that electric resistance backup, that's not so many hours out of the year. And you can work with a contractor to integrate that into your system so that it's pretty seamless for you to make sure that you're nice and comfortable all winter long.
Great. We have a question about the Inflation Reduction Act. Someone asks, how do I get the rebates in the recent federal legislation? And I just want to note that we had one of our staff members put in a blog about the Inflation Reduction Act that I definitely recommend you check out.
Yeah, I would defer to the blog on that one, just in terms of the specifics of how to start taking advantage of that type of rebate that's going to be available.
Another question, I have a ductless heat pump. I've heard I should keep the temperature the same all the time, but I want the bedroom colder at night. Any recommendations, suggestions?
Oh, that's a really good question. So I imagine this in the specific application, the ductless heat pump is in the bedroom, in which case, you can make the comfort adjustments that you need. If you have really specific questions about operation of your heat pump, please reach out to Efficiency Vermont and we can have that type of conversation with you one-on-one. But it's sort of, it is the case that in general, heat pumps that are kept at the same temperature are 24/7 or run more efficiently. So that helps you save money and save energy. So that's just a good thing to keep in mind as a general rule of thumb.
Great. We do have some questions coming about the cost to operate a heat pump. Someone asks, if I have both an oil boiler and a heat pump, how do I know when it's cheaper to use one versus the other?
Yeah, that's a good question. I believe there is a tool on the Efficiency Vermont website that helps you figure out that set point swap over. In general, though, with the volatile fuel prices that we're seeing, heat pumps are going to typically, in a well-weatherized home, be less expensive to operate than fuel oil systems. It all depends on the efficiency of the system. If you're using both, you can play around with it a little bit. These are systems that last for a lot of years. And so, it's going to be a little bit house specific. You can have good conversations with contractors. If you're really trying to figure out the specifics of where you might want to use one versus the other, again, please feel free to reach out to Efficiency Vermont so we can sort of talk through the specific details of your house if we get you one-on-one on the phone.
Great. We have a question about using a heat pump with wood heat. Someone asks, is it worthwhile to use a single ductless heat pump for the spring and fall days when temps go down to say 30 degrees and I don't want to use the wood stove, which is my primary heat source?
That's a great time to use a heat pump. Yeah, if you are trying to save, cordwood typically isn't terribly expensive compared to a lot of other fuel sources, but it's all situation dependent as well. And if you're hoping to split a little less wood this year, your back was extra sore last year, that's definitely a good thing you can do. The shoulder seasons is a time when heat pumps really shine. Once you turn the heat on with a heat pump, like I was saying earlier, you're going to typically keep it at that set temperature, and that's just going to bring comfort really most of the time. And then you can fire up that wood stove when it is really cold outside, and when you decide that's what you like. For a lot of folks, using a wood stove has a lot of appeal. It's really hot, it's really cozy. I love to sit around a wood stove at the end of the day. So that there's that appeal. You don't necessarily want to get rid of that if that's something you're interested in. But again, if you're trying to save some money on with wood, again, it's saving a lot on sort of sweat equity. A heat pump will operate super well all fall and spring for you, and then you can use your wood stove if you prefer when it's really cold outside in the winter.
Great, thank you. We have a question about air to water heat pumps. Someone asks, my boiler needs to be replaced. Can an air to water heat pump be used instead of a new boiler?
right? And this is what I was referring to when I talked about air to water heat pumps not typically being plug and play. It's hard in most situations to just pull out the boiler, boom, pop in an air to water heat pump. That comes down to those different types of distribution systems that you may have in the house. So if you've got radiant floor with certain designs or different types of radiators, you may be a good candidate for an air to water heat pump. If you do not, then there's more robust change that's going to need to take place in the house in order for you to swap one out for the other. And that's just what prevents it from being sort of a no-brainer, easy swap out. So when you're talking to contractors about air to water heat pumps, they'll know about this question, right? This is something that well-trained contractors work with a lot, dealing with the different distribution infrastructure that exists out there. And if they come in and say, sorry, that radiator is not going to work for this, that's what you know. But if they come in and say, oh yeah, these radiators are going to be great in this application, that's great, green light, that's going to be awesome.
Great. Another question, it says, you say heat pumps can work in sub-zero temps. Our contractor said we need supplemental heating. What's the real answer? I know we get that question from a lot of folks.
Yeah, heat pumps do work in sub-zero temperatures, and in existing home situations, you do often need supplemental heat. Those two things can happen at the same time because heat pumps may not provide quite as much heat when it's really cold outside, and it really depends on the home. If your home is weatherized, if your home has a layout that is sort of friendly to work with the heat pump, you're going to be able to, even when it's really cold outside, take advantage of that heat pump for the vast majority of your heating load. But it is the case that for a lot of homes, a lot of existing homes, especially if there's parts of the home that are impossible to weatherize for whatever reason, a lot of different situations out there that exist like that. Supplemental heat is a really good idea. As I was pointing out earlier, I love the combination of heat pumps and whatever your existing wood heating is. That can be a super efficient, really not a lot of cost to operate that type of system. So the answer to that question is they're sort of both true. They do work below zero, but supplemental heat is still a good idea.
Great. I think we have time for two more questions. Someone asks, will a ductless system cool the house as well as heat? How does that work?
Yeah, definitely. I won't go too much into the details of actually how heat pumps work. There's a lot of great resources online. And again, you're able to reach out to Efficiency Vermont to have this type of question answered if you really want a sort of technical breakdown of how a heat pump works. But the short answer is yes, it can do both. And in fact, heat pumps are cooling systems that have been reversed traditionally. That's kind of where the design comes from. So it will do both. And when you're thinking about long-term comfort, if you're investing in your home, and we get some hot summers, so having some cooling in your house can be really nice.
And someone also asks us on the chat if you could talk about how heat pumps dehumidify the air in summer as well as another benefit.
Sure. Again, if we want to talk a lot about super specific heat pump questions, please feel free to reach out to us and we can talk about your specific home and your specific needs. It kind of depends on what your system is and how you have it set up in the house.
Great. Well, I think we are actually at time. We have probably less than a minute, so I just want to wrap up. Thanks so much, Nate, for that great presentation and for all of you for attending today's webinar and for all your great questions. We tried to get to as many as possible. We're happy to follow up, and we'd also recommend you reach out to our customer support if you have any further questions. You can find the recording of this webinar as well as all of the previous Weatherization Wednesdays at the buttonupvermont.org website and our YouTube channel. And with that, I would say thank you so much and have a great rest of your afternoon. Bye, everyone.
Thanks, everybody.